All right, great. I'm going to get started because I had this idea of a talk, which is basically compressing like, I don't know, 20 years of software development into like 45 minutes. And I thought I would have time for Q&A, and then I tested this out. And it turns out that it's hard to compress 15 years into about 45 minutes. So I'm going to get started now. Thanks for coming out to my talk. Things maybe you don't know as a newer developer. I tend not to like to talk about myself in talks, but I feel like I do have to preface this with at least a little bit of a resume, just so that you don't think I'm getting up here and BSing you, because I know I look like I'm 20. So I've been a professional developer for 16 years. I did mobile for about a dozen years. And then in the last year, I switched from doing mobile to like Node.js, TypeScript, Elasticsearch, stuff like that. And my whole theory around this was that like most of the general developer skills I had would transfer. Like the framework is something I can learn quickly, and the developer skills are something that'll transfer no matter where I go. And it turns out that was kind of correct. And in the last year, as I've made that switch, I've been kind of like documenting all the stuff that was like generally useful to me, regardless of what framework or environment I was working in. And so this is essentially a culmination of that talk, and it happened to line up pretty well with like stuff that I just didn't know in the first 5 years as a developer. So I'm going to try to focus on generally things that I think are pretty solid advice that aren't too arguable. However, what you may know from programming is that if you ask any developer a question, especially the senior developers, they're going to first respond with, well, it depends. And that is the case with pretty much any piece of advice you can give about programming ever. You'll always be able to find a counterexample or some situation where the advice made no sense whatsoever. And I'm sorry about that. I'm going to do my best to be generally dependable about the things I'm saying here. So I thought I would go through kind of the general trajectory of newer developers, where you first start getting a job and you work on projects, and then you release it. And that'll be the vague outline of this talk. And so obviously the first step would be getting a job. And so here is all my advice for newer developers getting a job. I am not a recruiter or a hiring manager. I think it's really hard right now to get a job as a newer developer, and I'm very sympathetic, but I don't want to get up here and like spout off platitudes that aren't necessarily going to be helpful to you. There were other talks earlier today about careers and stuff, like go watch those recordings later. Those will probably be helpful. I wish I could help out more, but I can't. What I can do, though, is give you a few recommendations about things to look out for in your first few jobs, things that will help propel you to learn as a developer. First and foremost, I think it is very, very helpful to have someone who is a mentor at your first job. Someone whose part of their job responsibility is making sure that you improve as a developer. Now, not every place will be smart enough to give you a mentor. You can create your own mentor. That's the secret I'm going to give you here. Go to a developer that you like, ask them a ton of questions, and flatter them with compliments, and you can like reverse trick them into being your mentor. It works, trust me. People have done this to me. The second piece of advice I give is to work on meaty projects. So it is very easy to end up in a situation where you have a certain amount of skill, and your job will keep giving you projects that match your level of skill. And that is a great way to just stagnate forever. And that was essentially how I was for the first 2.5 years of my career, until I joined a startup that was like, no one here is going, like, you have to do everything, and so you have to learn. And that was like when I started skyrocketing my learning, because I was like, oh, I have to actually learn everything. So again, this is something you can affect. Instead of just accepting everything that your job is giving you, if they are just giving you easy task after easy task, ask for some hard, meaty projects to work on. The only way to improve is by going outside your comfort zone and making mistakes. And so hopefully what will happen is that you'll have senior developers on hand to basically like keep you from making too terrible of a mistake. That should be their job. Their job should be to ride this nice line between like giving you enough space that you can learn and make mistakes, but not giving you so much space that you take down the whole company. The third thing I'd recommend for like a first job or a second job is to be in real life. I have worked remote for over a decade, so I certainly know that remote work works. However, because I've been doing remote work for so long, I know what the downside is, which is that communication is really hard. And if your primary role as a newer developer is to learn, you want to be able to communicate really well. And so if you can find a job that's in real life, I think that's a better start, though any job is worth it. So like, if you can only find remote stuff, just do that. I have no way to solve that except for like maybe convince a friend to join you if you end up somewhere remote. All right, so now you have a job, you need to learn stuff. This is, and like I said, I think your primary role as a newer developer is to learn stuff so that you become a better developer. And in fact, there is no point in your career, at least no point I've run to it so far, where you stop having to learn things. And in fact, like the start of every project is like me like this. And I kind of hate the start of every project because it makes me feel so dumb being like, well, how do I use Elasticsearch? I've never heard of this before, and now I need to suddenly figure out how to use like aggregate filters and crap like that. So learning how to get this learning stage in the past for any given project is key. What I think is useful is to think about all the places that you can learn from. So this is just a ton of information. This is not even all the sources. I didn't put ChatGPT on here, but a bunch of people are recommending that these days. You can Google things, look at documentation, official or unofficial. People have written books and articles, go to classes, go to talks like you've been going to all day here, code samples, Stack Overflow, doing code exercises. Reading open source code can be helpful. That was very helpful when I was working on Android, just being able to read what the Android code itself was doing, and just asking other people. I think the real key is not to try to learn through all of these methods all the time, because that's way too much work. It's to figure out, for you personally, which of these ways works for you. So for example, when I'm learning a new framework or language, I've learned that code exercises are my favorite way to learn, because getting my hands dirty just works better than me like reading a book or watching a class. That's just me personally, though. It might be something different for you. I do want to highlight two in particular. The first is Google, because Google or Bing or whatever you use, DuckDuckGo, is like a superpower because you can basically ask any random question you have, and someone probably on the internet has written about it before. Programmers are very generous and like share their knowledge freely in general. At least someone does online, and it's amazing how much you can find. And then likewise, asking other people, especially your coworkers, is awesome, because they will give you so much information. I actually think that asking questions is kind of a superpower because a lot of newer developers don't ask enough questions. And actually, like, I think what happens a lot of the time is this feeling of like imposter syndrome. That like, if I ask questions, it makes me look dumb because it makes me look like I don't know something. And I want to say that first, senior developers who see people asking questions are not thinking that you're dumb. They're thinking this is a chance for me to show off and tell you all I know. So just keep that in mind. Second, learning is one of the ways to get across imposter syndrome. Once you actually embrace more and more knowledge, you build up your knowledge base, you feel a lot better about this. And also, as an aside, another way to get past it is by slowly realizing that everyone is human. You will work with more and more senior developers and realize that all of them make mistakes all of the time. For example, I theoretically am a senior developer. I have to Google all of the joins on SQL tables every time I want to do a join, because I can never remember what the fuck is the difference between a left, a right, and inner join. Now, I do want to mention one problem that can come up when you're asking a question of someone else. So here's an example. One person comes to another and says, how do I get the last 3 characters of a file name? And they might know the answer to this, but they realize, wait a second, are you actually just trying to get the file extension? Because if you're trying to get the file extension, not all file extensions are 3 letters long. You know, it could be 1 letter, 2 letters. Some files don't have file extensions. And so what's happened here is that the woman on the left had a problem X, which is I need to get the file extension. And she thought, oh, a solution to that would be if only I could do Y, then I could solve that problem. But they don't know how to do Y. And so they go to someone and they ask why. But that's not really the question they should have been asking. They should have been asking about X in the first place, because there was a better answer overall than Y. And so my suggestion here is whenever you go and ask someone a question, ask your specific question in context. So in this example, you might go to someone and say, hi, I'm trying to get the file extension for a file. I've been trying to figure out how to get the last 3 characters, but I can't figure out how to do that. And at that point, you know, if your why was the correct answer, they can help you out with that. But if it wasn't, the dev can be like, wait, back up. We actually need to talk about this a bit more. Another thing I'd implore you to do when you're learning is to take your time and actually understand what you are copying and pasting from Stack Overflow. A few reasons for this. First, there is a lot of garbage code on the internet. There's a lot of blog spam. You can tell because they just copy and pasted an entire GitHub project into like Blogspot or something. There's so many shitty pieces of code out there. If you understand it, you can take the Stack Overflow code sample and actually make it your own. So much of programming is about modifying code after you've written it. And so if you understand it, you will be able to modify it later. And then again, you are trying to build your knowledge base. If you are just getting things working one thing after another, that's great. But all you have at that point is a working application, and like great for the company, but for yourself personally, you should be learning more, I think. All right, let's get on to development. The actual, like you've learned, you're actually going to work on something now. If there's one thing I want to emphasize in this whole talk, it is this one idea, of which almost everything the rest of which I'm going to say is based around this idea, which is that software development is a nonlinear process. So what do I mean by that? If you work, say, like making widgets at a widget factory, if you want to make more widgets, you could just work a little bit faster. Or you could open up another production line. That is not how software development works at all. Working just a little bit harder does not make the software come out any faster. And adding another developer often actually slows things down for a time. Instead, there's all these things you can learn where if you just are smarter about the way you do software development, that's how you can cut down the development time dramatically. And so I'm going to give a whole bunch of examples of that through all of this. So for example, planning. Before you actually start a project, you can try to plan how you're going to solve it instead of just jumping in and writing code right off the bat. Something I definitely didn't do for the first few years. You kind of want to scale the amount of planning based on the size of the project. Obviously, if this is like a 1-week project, you don't really need to plan all that much. But if it's like a 2-month project, like spending a couple days just figuring out where you're going to head is a good idea. There was a project that took me like a year and a half to do. I must have spent the whole first month of that project just planning and prototyping. So here's how I go planning. Sketching out a solution. This is not like a technical design or something. It's just like me writing down basic ideas of like how I think I'm going to solve it. And then I write a prototype. And this prototype I consider to be completely throwaway code. Like, it's great if some of it happens to end up to make it in the final product, but really, I'm just trying to prove out that the sketch I made is something that will actually work in the end. And you end up learning so much through just writing up a quick prototype. And you're not caring about corner cases. Maybe you write it so that the SQL queries don't like work at all. They just find one particular item that you know the idea of or something like that. But you prove out that the flow from start to finish works. And then you take these two things and you talk about it with other people and get their input, and they can help you out more. So now you've planned. You're working on your plan. You're trying to come up with your design. And when I'm talking about design here, I'm talking about it in two contexts. Like the design of the feature itself, like maybe how the UI looks or how the logic of it works for your business logic. I'm also talking about the code design, like how you actually implement it in the code base. And the thing I want to emphasize here is that there's almost never one correct design. There's almost always, like rarely, I mean like maybe once ever I've experienced one where it's like there's obviously the right way to do it. There's almost always trade-offs with whatever you're working on. And so it's worth taking the time, especially during the planning phase, to figure out what those trade-offs are so that you're picking the right one. One of the things that I focus on a lot is trying to save time by avoiding perfectionism, where if someone gives you a feature spec and you just accept it unquestioningly, it might turn out that like part of that feature spec was really hard to implement in your code base because of like some tech debt that you had. And it turns out if you just ask them to change the design a little bit, it would make it so much easier to solve this problem. And I think as a newer developer myself, I always thought that when someone handed me a feature spec, that was like set in stone. That this was something that someone was giving me because they thought about it a long time and they wanted these exact features. But it turns out everything is negotiable. And you can go back to them and say, I like all of this, but like, what if we tweak one thing and we can save so much time? This actually happened to me pretty recently, where we were working on some permission stuff with some software, and there's like 3 global admins in the entire piece of the program, and there was one weird corner case with those global admins, and the solutions we were talking about would have taken like 2 weeks to implement. And after a half-hour discussion, I was just like, why don't we just not do it? There's only 3 of these global admins. We just won't let them do this, and it doesn't stop us from doing it later. But for now, we saved ourselves 2 weeks of work. And we saved ourselves 2 weeks of work. That's the nonlinear part right there. Not doing work is better than doing work. Along the same lines, like I just mentioned, part of the reason I could make that call is because of this one-way and two-way door metaphor. So with a one-way door, you have like crash bars, there's a fire inside, you push through the crash bars, you're on the other side, and it's like, okay, I'm through, I can't go back now. A two-way door is your standard door, like the door's right over here. You can go back and in, you can decide to see my talk and then leave and then come back and come in. Anyways, if you prefer two-way doors in your design, that is basically saying like, the choice I'm making now doesn't block me from going to the other choice later. It makes it much easier to move forwards with any given choice that you have. So you figured out your design. Now you actually need to implement it. And I will tell you how I implemented things when I first got started, which is I would have a feature. I would go off in my hidey hole for 2 to 3 weeks, write a whole bunch of code, and then be like, here's the feature. And I would implore you not to do it this way. It is so much better, and in fact, in my mind, critical, to be able to subdivide a task into smaller and smaller tasks and be able to work on it piecemeal. So multiple small tasks, much better than one big task. And here's a few reasons why. So for one thing, I think it's just a lot easier to develop. Conceptually, when you split up a large problem into smaller problems, each one of those small problems is hopefully something that is easily solvable. If you worry about the problem as a whole, you can get overwhelmed in all the complexity of it. And this is something where senior developers can really help out. They can really help out and come in and say, like, here's how I would split up this problem. First, I'd work on the schema, then I'd work on the data layer, then I'd work on the API controller, then I would add these tests for the business logic, whatever. They can help you out here. Once you actually get some work done, it's easier to review the code. With code reviews, the amount of time it takes to understand the code is not linear. Like a one-line change is like much easier than a 100-line change, and a 1,000-line change is like crazy, because whoever's reviewing it has to keep all of the changes in their mind at once to be able to understand it all at once. And if they're only seeing 10 lines of code, they can keep that all in their head. If they're seeing 1,000, they can't. Likewise, once they reviewed your code, imagine now someone comes to you and says, the solution you came up with will not work. Like, it turns out it's not performant enough. The way you wrote this query is going to crush us, and you have to change the solution. If you went away in your hidey hole for 3 weeks and came back with a solution that doesn't work, you've just wasted 3 weeks of work. If you did this piecemeal and say this is like on day 3 of the work that you put forward a pull request that's like, here's the solution, and then it doesn't work, great. You've only lost like a couple days. And that's actually not a big deal because that happens in software development all the time. But you want to figure that out much earlier rather than later. And then finally, it's easier to merge the code. If you're working with like a dozen other developers and they're all changing the code base, and then you want to merge in 3 weeks worth of changes to it, that's a nightmare. And in fact, not only is it a nightmare for you to merge it into code that you don't understand because you haven't been looking at it for the past few weeks, that's also a wonderful source of bugs, merging into people's code. Now, I think part of the reason the initial instinct is to work on a whole feature at once is that it is hard to conceptualize, how do I work on something when it's only half finished? Like, how do I check in code when this is an incomplete feature? And so I'd like to advise 2 ways to do that. And the first is to avoid a final hookup. So suppose what feature you're working on is like, the user presses a button and then a whole bunch of stuff happens. Don't add the button. Just do that last. Add all of the other logic first, and then the last thing you do is the button, and you can keep inserting all this code, and it doesn't affect anything. And the other one is very similar. It's to use feature flags. And feature flags at its most similar is basically a Boolean, where if it's true, you show this button. If it's false, you don't show the button. And I actually think that essentially once you get above like a few developers, feature flags are somewhat essential just to like be able to work on a code base together, a shared code base together. Otherwise, it just gets too unwieldy. All right, I'm gonna go over a few acronyms that you're gonna see come up, but I think that these are all generally good. There are definitely a lot of hot takes on the internet about why this acronym doesn't work sometimes, and like, I get it, but like 90% of the time, these are gonna be correct. So the first is dry, don't repeat yourself. That means if you are doing the same thing multiple times, think about putting it in a subroutine instead. It sounds obvious when you say it like that, but it's getting that instinct to recognize when you are repeating yourself can be a little more subtle than you'd think. The second is Yagni, you aren't gonna need it. So that's where you've got some project you're working on, and you anticipate, oh, I've written features A and B, but maybe someday we'll need C, so I'm going to write down C just in case. It's easy for me to add it now. It turns out really that like 95% of the time you don't need that thing that you just added, and you wasted your time actually. Even though it seemed like it was easy now, it turns out you didn't need it. And maybe it even makes it harder to like take it out later. It just becomes code rot. So most of the time, you don't need it. What is better to do is to write code so that it's flexible and maintainable, so that if you do need it later, you haven't blocked yourself from adding it. And the third is keep it simple, stupid, which is like complexity is the code base killer. That is what makes code bases hard to work with, is when they get super complex, and code naturally trends towards complexity. So you have to actively fight the complexity by trying to keep your code base simple. So to go a bit more into example about that, I really wanted to have more time to go over like a bunch of things that I believe to be true in like any language or framework, but this is all you're going to get of that because I didn't have enough time. But example of how to keep complexity down is that in general, I think that the more states that you have possible in your app, the more complex it gets and the more potential bugs you have. So what do I mean by that? Well, a simple example of this is using enums instead of a stringly or numberly typed things. So for example, imagine you have some function that returns top, middle, or bottom. You could have it be returning the strings top, middle, or bottom. You could have it returning the numbers 2, 1, and 0. Okay, that works, but what happens when something that's ingesting that ingests the number 3 or the number 1000? Like the state space is actually huge because integers are huge. Or the state space of strings is ginormous because strings are infinite, basically. Whereas if you have an enum, you're saying only one of these 3 possible things can exist. And so it's much simpler to work with that because it has fewer states. Likewise, immutability over mutation. I don't know if you went to Paul Contrell's talk about things that he thinks are going to be phased out of languages in the future. I totally agree with him about this. Immutable data structures are so superior because it is so hard to reason about something when it's constantly changing on you. This is especially a killer with concurrency. If you have one object that multiple threads are accessing and they're messing with that object, you will deadlock somewhere. There's no doubt about it. The thing that always confused me as a newer developer hearing about like make everything immutable was like, but wait, programs are all about changing things. How can you write a program that changes things if things are immutable? Well, the answer is you always invocate a new instance of something. So you say, I want to have a new instance where like this is some child object, they've just aged up. I want to have a new instance where their age is +1 or something like that. And it turns out that computers are fast enough that they can handle this. Pure functions over side effects. What do I mean by pure functions? A pure function is one that takes inputs, doesn't modify those inputs, and then spits out some output as a result of it and does nothing besides that. It is very simple to reason about a pure function because you know all of the possible input space and you know all the possible output space. A side effecty function is one that can like throw an exception. It's like, oh no, I didn't know this could throw an exception. This is some unexpected state flow. It can like not only, because of the way exception handling works, it can not only skip the caller, it can go way up to where the latest try catch is or whatever. So yeah, these are ways to keep it simple. I'm gonna have a drink of water for a second. I have to do something to keep myself satiated while I do this like Micro Machines speed talking. All right. Code review focus. So when I first started doing code reviews, I thought that the thing that I should look for is everything. And I'm here to tell you that is not true. I'm here to tell you that there is actually different things you should focus on more or less in code reviews to get more bang out of your buck and to have more signal versus the noise of normal code reviews. So I think of this as a pyramid where on the bottom, where you spend the most of your time, is the most important stuff, and at the top is where you have the least important things. And this is not meant to be a comprehensive list of the things you should be reviewing, just kind of examples of the things I think about. So at the bottom layer would be things like APIs. When you release an API into the wild, it's very hard to change it because other people immediately start depending on your API. And then when you can't change it later. So like getting the API right is important. So talking about that is like the primary thing. Your architecture. Does the architecture make sense? Will it be maintainable? Will it be flexible in the long run? Maintainability, next step up. If it's not an architecture, it's still whatever level you are. Will it be flexible enough to change it later? Readability. Your most code is like written once and read like 1,000 times. And so is this understandable to other people is important. Do you have enough tests for it? Are you covering the bases so that someone else who wants to change this code later will be able to review it? And then maybe at the top are bugs. I think people, definitely the thing that people think code reviews are for is bugs. But you will never find all the bugs in code reviews. Bugs are slippery sons of bitches. And like, if we could find all the bugs in code reviews, that would be fantastic, but you just won't. If you can find a bug in a code review, great. Mention it, fix it. But it's not like the primary purpose. So like things to avoid, things I didn't mention that you might be wondering about. I explicitly did not mention them for a reason. Don't talk about code style in code reviews. If you care about code style, use a code formatter or a code style enforcer. You don't need humans involved with this. It just annoys people when you point out code style issues. Like, oh, you forgot a semicolon in this JavaScript file. Use Prettier to put the semicolons in automatically. Don't put that on people. Similarly, syntax. Turns out in JavaScript, there's a lot of nightmarish syntax you can write that you should never write. And so we have things like ESLint for that. And again, don't put it on people to handle this. Put it on the compiler. Put it on the linters to do this for you. And the last one is preferences. This in my mind, this is any time that someone writes code where it's like, you know, I wouldn't use that type of for loop. I'd use a while loop with a break instead. And like they don't have a reason for it. It's just that their personal preference is to use those while loops. It just comes off as really asinine. It's kind of like when you write an essay and someone like just suggests a bunch of edits that don't really have anything to do with the substance of the essay. It's just that it turns out you as another person write in a different style than they do, and they want you to conform to them. So these are all I put in the category of nitpicks. People love to use the word nit before saying something in a code review, being like, don't worry about it, it's just a nit. They forget that the definition of nitpick is an annoying little thing. So just avoid that. Instead, I would embrace questions. It's great even if you don't have a problem with the code, just being like, hey, I want to learn more about what this code is doing. Can you explain this to me? That's a cool use of a code review. Use it for discussions. Say like, I don't understand where this architecture is going. I guess it's a question too, but like, you can discuss back and forth what the ultimate architecture is going to be. And also, something people don't think about enough, compliments. If you think some piece of code someone's submitting is awesome, fucking tell them. It feels good. Along those same lines, being a good teammate. There are teams I've worked on that have worked together better and ones that have not worked together better. And these are just things I've noticed within those teams. First is the teams that have worked really well together kind of had an ethos of helping out each other as much as possible. And in fact, like in one team, we actually emphasize that like help others before you help yourself, basically. And that's because software development, unless you're working alone, is a team sport. And it's not like you go on the soccer field and like everybody just plays on their own. Like you are working with other people. And so actively unblocking people, sharing your knowledge as much as possible has this multiplier effect. Get stuff done. I guess this is obvious, and yet it's not. I've worked with a lot of people where they will, I guess, I don't know, feel ashamed of their bugs and then like put it in a corner and not want to work on it. Or they don't want to acknowledge that it exists. And then it's on someone else to do that. Or finishing projects is a real pain in the ass because the first 90% is a fun ride, and then you have to worry about all these stupid little corner cases and all these things that the QA found or whatever, and some people like drop off at that point. And again, someone else has to pick up the slack, and it's a real pain in the ass. But also it means, in my mind, sometimes you step out of your role a little bit to just get stuff done. So like if your manual tester is out on vacation, step up and do it. If your managers are sort of lacking, you can kind of self-manage yourself a little bit. Like your defined role, I'm not saying like go out and work 20-hour days and do everybody's job for them. I'm just saying don't be so narrowly focused that you're like, all I do is code. It is sometimes very helpful to step outside of that role a little bit. And again, this should be obvious, but it's not. Don't be a jerk. This was not necessarily obvious to me. it was not that I was actively trying to be a jerk, but there are a lot of ways that you can accidentally come off as a jerk. So use tact and empathy, be nice. For example, like in code reviews, if I'm talking to someone else and I say, hey, I think that loop's gonna be like n squared, I think we should probably improve it. They hear that tone of voice, they're like, oh, okay. Dan's a little concerned about it, not a big deal. If I write that same thing down in text, like the tone might come off wrong. They might think, oh, he's being terse, like it's really terse, and it's like, oh, Dan's mad. Dan's mad about this algorithm. So like when you're writing online, you can try to use tact and be nicer and have empathy. Be humble. Put aside your ego a little bit. So, anyways, it's not just about explicitly not being an asshole. It's about also understanding the context from which you're coming from. All right, enough about development. Let's talk about testing. You've gotten your thing done. You need to test it. There's really two styles of testing. Two main styles of testing. There's manual testing, which is where you go through whatever you just did and check off all the boxes yourself. And then there's automated testing where you write software to do it for you. The natural thing is to do the manual testing because that is what anyone on Earth can do, is test it themselves. Automated testing is unnatural and feels weird, and that is why I didn't do it for at least 5 or 6 years as I started as a developer, and I'm sorry about that. So let me try to convince you why you should automate, why you should get into this. Now, I actually, at a previous minibar, I gave a talk that was basically like, you do need some amount of manual testing. You will always need some amount of manual testing. However, automated testing is fantastic, so you should do that a lot too. You want both. So why automate? First, it's repeatable. You write a test, and you can run it over and over and over again for years to come, always checking that that one little piece of logic works the way you intended it to work. Whereas with a manual test, you will probably test it while you're developing it, and maybe the moment you release it, and then you will never manually test it again until someone's like, hey, why doesn't this work anymore? And then you go back and be like, oh, shit. It is fast. If you write your automated test correctly, they will run like 1,000 million times faster than you will ever test your own code. And then the third thing is safer refactoring. This is not a comprehensive list, by the way. There's all sorts of other reasons. These are the 3 I wanted to highlight. The safer refactoring is because if you have this huge amount of automated tests that tell you how all the logic of the system works, and you need to change some of the internals of the system, you can do that, and now you have this wonderful test bed that will tell you, I didn't screw up logic that other people were relying on. And in fact, there was a book that I read once that was like working with legacy code, and essentially the TLDR of that book was write tests, then refactor. Now notice I said safer refactoring, not safe refactoring. They can never guarantee safety. Automated tests are only as good as you write them. You can always have unexpected things that you didn't realize you were screwing up, but it does make you feel a lot better to have a bunch of tests. And in my mind, and this is one of the more controversial things, I know there are people who disagree with this concept, test-driven development. This is where you write tests as you're developing. And I actually really like this as a style of writing tests. I actually think it's a huge pain in the ass to write tests after you wrote the feature, because then it's like, oh, I got it done, and now I'm just spending like a week doing nothing but verifying that what I got done is done. It's boring and dumb. It's much more fun to do it while you're developing. Why? Well, first, I think it actually makes you faster. Now, this is counterintuitive because it's like, wait, I'm writing more code because the automated code is more code on top of whatever feature I was writing. But what happens is, as you're developing something, you're always manually testing it. You write a little bit of code and you run it. You write a little code, you run it. If that manual test takes 100 milliseconds, that's super fast feedback. And in fact, if it takes little enough time, you can have it run like every time you save the code. It can just run and tell you the moment you hit green, the whole moment things are correct. So it ends up being faster in the end. The second great thing about test-driven development, it lets you verify unfinished features. So I was talking earlier about how you hide work. Well, if you're working on things piecemeal, that's a very hard thing to like verify that it actually worked. Because like, wait a second, I worked on like the database layer, but how do I access the database layer in my app without having first written all the buttons to get there? Well, if you write an automated test, you can write a test that just tests the database layer, and then you can verify that that one little piece of work worked. And the third, and this is going to be the most hand-wavy thing I say, a lot of the reason why testing feels awkward when you first get into it is that you are writing code in a way that is hard to test. And I wish there's whole talks you can give about this topic, which is why I'm hand-waving here. I just want you to trust me on this, though, that when you write code that is testable, it naturally ends up being a better architecture as well. Just kind of through the nature of how it turns out that good tests or easy to test code comes out. A few thoughts on testing though. First, be tactical with test coverage. I think this is one of the things that tripped me up at first, was the idea that I had to test absolutely every corner of my app. And in fact, there are some people that think that's what you should do. I think that's a waste of your time, because like, there are some parts that are easy to test, and there are some parts that are very hard to test. And the parts that are very hard to write automated tests for, is it worth your time writing the test if the payoff is very small, potentially? Maybe it's better to have someone do that manual test every once in a while. So being tactical with what you want to cover. The second is that flaky tests are worthless. If you have a test that is failing 25% of the time, that is not helping you in any way, shape, or form, because you never know if that test is actually passing or failing. So if you have a flaky test, either delete it or fix it. And the third is there is a hybrid approach to manual versus automated testing. It's not an either or. You can also add tools to make manual testing easier. So for example, we had on Trello Android, we had this chaos monkey thing injected into it. So we were writing the app to work offline, which meant that we would be able to keep functioning even if we lost network connectivity. And so we wrote a layer that essentially automatically dropped network calls randomly, just so that as you were manually testing, you might just happen to run into a bug with our offline mode. Or you can write tools that like highlights in like bright green when something seems to be going wrong, just so that someone looks into it or on like a dev build. All right, debugging. You found the issue. Now you need to solve the issue. How do you find out more information about the bug? Print is the obvious answer. It's fine. Plenty of people use print. I still use print plenty. But I want to make a play. Debuggers are better in general. And here's my metaphor. If you are called in to solve a crime, print is like taking a picture of the crime scene. All right? And you can maybe solve it. You know, I had those books as a kid, like the solve a murder mystery on like this one double-page spread, and you look for the clues and figure out like, oh, who did it based on that. But it's hard. A debugger is like getting to stand in the room and look around at everything while the crime is happening. Which one would you rather have? So debuggers are not that scary. They feel scary because getting them to attach sometimes, depending on your code base, can be a real pain in the ass the first time you do it. But once you figure out that first time, it's usually way easier afterwards, because you realize, oh, the only reason that the debugger wasn't attaching was because, like, I don't know, the way that Node was starting up turned out to like reject the debuggers, or maybe I wasn't generating source maps on TypeScript or something. But once you get that past that initial hurdle, you start attaching debuggers all the time. It makes life great. All right, releasing. First, talking about hitting deadlines. This is good because I've got like 6.5 minutes or something left. All right, about deadlines. All estimates suck, so deadlines are often incorrect. I think you can, having done this for so many years, I feel like one can estimate on the order of magnitude, but they can't really estimate on the number of that magnitude. So what I mean is you could say, this project will take a day, or it might take days, it might take weeks, it might take months, or it might take years. But the number is not for you to know. So will this take 1 month or 3 months? I don't know. And here's the thing that happens, especially for newer developers. You are missing your deadline, and so you try to work harder. And then you burn out in a glorious, bright flame star, and you go work somewhere else. I have better answers for than that. At least other options to try before burnout. The first is to overestimate. Everyone tries to do this. You don't want to super duper overestimate, and people will super duper overestimate and they still mess it up, but whatever. Give yourself a little bit of padding though. Cut scope. When people want to get the feature out, that's when you can do the best negotiation. It's Monday, they want to get it out on Friday. You say it's not possible unless we get rid of this one dumb thing that was hard to program, and they're like, fine. Again, with that avoiding perfectionism thing, cut scope. The third is to let deadlines slip. It's really nice and healthy. The healthiest place I worked was where deadlines were not super duper strict. Now, this can be a dangerous trap because you can end up in a place where deadlines never happen, where you never release. That sucks too. But having a little bit of leeway where it's like, it was supposed to be due this Friday, we can push it off to next Friday, that makes such a world of difference. And in fact, like, you don't need to crunch. I was at Trello Android for 8 years. In that entire 8-year period, I did not crunch once. You don't, like, making successful software does not require crunching. I can't say that for all of the Trello employees necessarily. I don't want to speak blanketly for everyone working at Trello that no one ever crunched there, because I don't think that's true. But like, you can get good software done without crunching if you do these 3 things instead. One of the key things here though is to like, all of these sort of require seeing it coming. So the moment you see that the deadline's not going to happen, that's the moment you start bringing up these things. And last point I want to make this is just speaking from personal experience here, very personal experience. When you're going to release software, don't do it before a weekend. Don't do it before a holiday. If it goes badly, you do not have the weekend or holiday anymore. Don't do it when fatigued or tired. I've done releases that seem like they need to be done at conferences, at multi-day conferences. Oh my God, it was bad. Don't do it when in a rush. There was one day I released an app 4 times because the first 3 times I fucked it up because I was in such a rush. It really takes some time to step back and be like, okay, have I really fixed this? Because spending an extra 30 to 60 minutes is better than spending the whole rest of the day fixing your rushed release. All right, that's all I've got. Thank you very much for listening. I'm vaguely active on Mastodon if you want to get a hold of me. I took this right to the limit, so I'm sorry I don't have a super amount of time for Q&A, although I will be around for drinking out there at the after party too, so if you want to ask me questions out there. But I have time for some questions here as well. Plus, this is the last question, so I guess we could go on forever, potentially. Anyways, any questions about anything development related? Love them. I love code comments. I think they got a really bad rap for some reason because people were writing comments that were kind of worthless, where it's like, add and it takes 2 integers and it spits out an integer, and they're like, adds 2 numbers. Like, that's not a very useful comment. But like, comments that explain the why or the how of something are fantastic. So there's some particularly complicated piece of code, and it's like, 100-line algorithm. Making someone read through that 100-line algorithm to understand how it works sucks. Instead, just give like a 2-sentence summary at the top where it's like sorts like clusters by k-means and then picks the top 3 elements or something like that. Like, gives a nice top-line summary of like what's happening there. The why is great too, where like you write some crazy hack in or some solution that seems like it sucks and is dumb, and you're like, I had to do it this way. And here is why, so that you don't come along looking at this saying like, this looks bad, and don't understand the reason it looks bad. There was a reason for why this is the way it is.
Do you have any experience navigating maybe like a work environment where things are extremely locked down and it's very hard to get a hold of like new tools or frameworks, and any advice on that?
Advice on a place that's super locked down. Unfortunately, not really, because I have not worked in those environments all that much. Yeah, I'm sorry. I would love to just make up some answer, but like, I would prefer to be humble and say I just don't know. Sorry.
How do I prepare for a whiteboard technical interview?
How do you prepare for a whiteboard technical interview? I think that the thing that I would do is not just whiteboard technical interviews, but any interview. What's really great is to reach out to the recruiter and ask, is there anything you can tell me that I need to prepare for this interview? I think the really good recruiters send that proactively. But a lot of them will actually send that information to you if you just ask, which is like, why don't they send that to everyone? I don't know. So that's sort of my advice, because then they can say it's going to be a whiteboard thing. Study blah, like it's going to be about this. It's going to be about you're going to try whiteboard designing a game with someone. Like I don't know, like that happened to me once in an interview where someone had me whiteboard like a game engine on the screen, and I was like, I don't know game engines. Like I've never worked in video game stuff, and like maybe you worked in video game stuff and that's why you were talking about this, but like I have no concept of something that needs to loop every tick and like update game state and stuff like that. I still don't really have that concept because I still haven't written video games. But if I had known going into that interview that like we're going to talk about this, I could have studied it for like 5 seconds and known. Any other questions?
I don't know if this counts as a question, but general advice. I like write doc strings and write docs in general. You help others, and there's always the oh, I need to explain this. Now it makes more sense to me.
So you're talking about like as you write down documentation, it also helps you understand it as well.
Yeah, if you can answer just what does a generic person need to know about this, you'll often find things you just sort of implicitly knew.
For sure. I 100% agree with that. Um, I do think that like being able to explain something to yourself and to others does tend to increase your knowledge of that topic, which is why they have that old song about like teaching actually teaches the teacher more than the students or whatever. And yeah. Is that all? Oop.
When you're so when you said like everything is negotiable, when you're getting a feature and you're talking about um, I'm a emerging engineer, you'd say, and like I totally experienced the effect of like somebody gave me a ticket. I thought this was set in stone. This is exactly what they want. I can go in my Heidi corner and make sure it meets the requirements. But I have it took several sprints of that where I realized, oh wait, this ticket became something I completely didn't think it would be from the start, and actually became like four other tickets.
Oh yeah, that happens all the time.
Like I didn't, I wasn't expecting that. I totally thought this had been thought through, and that's why they're letting it associate.
And in fact, what happens a lot is that you'll get a problem again with that nonlinear thing, and realize that like this little problem is actually a big problem. And like yeah,
Do you have any advice on like emerging engineer taking a ticket on the questions to ask or how to analyze that from the start?
yeah. So I think the problem you describe where like one small ticket suddenly becomes like four bigger tickets, that's something that still happens to me all the time. Like there's no way to avoid that, because usually what happens is people like you always have an idealized idea of what the solution is going to be when you start, and you don't realize what the roadblocks are going to be until you get there. So instead of, I wouldn't view it so much as like what are the questions I need to ask up front, because I think the questions you need to ask up front are just what you would ask of anything, which is like, can someone please explain to me what you want out of this? And maybe you can ask one of the this more senior developers like, do you have an idea of how to get started on this? I think what's more important though is once you start recognizing that things are not working out the way we expected to raise your hand at that moment. Don't wait until the very end and be like, oh, actually, like I've kind of just been freaking out about this for a week and didn't tell anyone. Like the earlier you raise that, the better. And that actually reminds me, like so much of my advice to people, like people will come to me and say, like, "Hey, Dan, you're experienced in this part of the code base. How do I do the X?" And I'll say, "I think maybe you should do Y. Like, I think that might be the solution." But I always now caveat that with like, but I'm not the one doing it. And so like you may start off and you're gonna find out within like 2 hours that what I told you is completely wrong and dumb because of like some line of code, some constraint that we had that I forgot about. So many times, my initial thought on how I'm going to solve something is not the way I end up solving it. Um, so yeah, just I guess what's more important than preparing there is just being ready to pivot if necessary.
Managing expectations.
Yeah, exactly.
Do you have any like tips or advice or just opinions on version control and like branching strategies in a
Oh
time?
yeah, I do.
I like my curiosity is like especially around like commit messages because there's like very strong opinions within my organization on we follow conventional commits pretty closely. Not sure if everyone does that.
I'm not super familiar with conventional commits. Um, Also, don't feel like you have to stay here because I'm talking and talking. If you want to go get drinks, please like leave. I'm happy to just keep talking here because then like it'll get more on the recording, I guess. I'm not super familiar with conventional commits. I think in general, putting a lot of info into Git commits is great because uh, what those are for is what a Git commit is for twofold. The main thing is to get code into the code base, obviously. But the second thing is for someone to find out why the fuck that code was in the code base 3 years down the line. All right? And no one will remember why that code was in the code base 3 years down the line. But if you have a nice long commit message that explains why this code is here, oh, it makes such a world of difference. And it's also like if you're doing some reformatting of a file, make that a separate commit. Then when someone sees that commit, they're like, oh, I can ignore this because like that person didn't actually change this. Whereas if you reformat and then also change logic, then it's hard to separate where did the logic actually change versus just the file change. Yeah, I love it. Git praise. We're not supposed to call it Git blame anymore. Git annotate. Well, there's a bunch of synonyms for the same feature where you can see who wrote each line of code. There's a really cool tool. The other talk I was thinking about doing this year is all about Git, actually. There's a really cool tool called gitlog-s where you can search through the code base for an instance of a particular addition or subtraction. And so you can be like, some function used to work and it doesn't work anymore. I'm going to do gitlog-s this function name, and then like it'll find all the commits in the past that ever added or removed that line of code, or a line of code that references that particular text. And then it's like again with those cool git commit messages, then you can find out about that. And yeah. No, I don't like squashing commits particularly. Again, because I think that the commit history is so valuable that I'm like, I want to know everything that happened to get us to this point. And like, what are you like when you're squashing? It's like, what are you? It's a little cleaner now, but like, you're not you. Who's going through being like, oh, 3 years ago we did 4 commits instead of 1. Damn it. Like, no, it's I would keep as much information as possible. And then in terms of branching strategies, I prefer like branching strategies that are simpler rather than more complicated. Just and not to get too deep into the weeds of it, but like you can end up with these. The one thing that I really try to avoid is long running feature branches. So like we're doing a big refactor, and so we should take it on another branch, and this other branch will be running for 6 months, and then we're gonna try to merge it back. It's like, oh my god, no! Like it's the merge is a nightmare. Things diverge so much that it just becomes bad. So that's the main thing. It's no long running feature branches.
Do you have any advice for building a meaningful, like mentor, quote unquote, student relationship in a fully online workplace?
Not really. Do I have any advice for how to build a meaningful relationship in general? I don't think I'm that good at interpersonal relationships to necessarily be able to give that advice. Um, I just generally know that the longer that you work with someone, the more you become connected with them. And I think that it also helps to not think of it as just a professional relationship. Like I think that I'm not saying like your best friends should be all the people you work with or something like that, because I think that's toxic too. But you shouldn't also just be like, these are my coworkers, and when I leave at 5 o'clock, I forget their existence and I don't care about their feelings outside of work. Like, be friendly. We used to do like remote hangouts where we play like Jackbox parties online, like between our just the coworkers. We'd like have remote lunches where we'd like get meals and then just like eat and hang out and talk about life. So yeah, there are ways to. That's not specifically to like a mentor team, but just like ways to stay connected to any sort of remote team. Oh yeah. I don't know. Can you guys? Oh yeah. Something that's been helpful for me in my last position, I was working almost exclusively with one senior dev, and we hit loggerheads a lot. Like you were saying, you know, like if you write something out in text, we would almost always misread each other's tone. But if we actually talked to each other, that was a lot more beneficial for us. Or like realizing that, hey, we both appreciate communicating in GIFs or memes, right? Like whereas sometimes that's not so like kind of what strikes me about that, and I have a previous career in HR which underpins some of this information, is like get to know how you communicate, and so that you can identify that and advertise that when you're communicating with other people, because that's how you find the people you're going to be able to actually have the most productive conversations with. Like rather than just banging your head against like, I don't understand how to get this person. I can't seem to figure out how to talk to them. I'm just gonna keep trying. Like maybe that's not the person to try to build a relationship with. For sure. Like I know that I have a very blunt style of communication, and so a thing that I have worked my entire career towards is like unblunting that basically to use more words in a way that makes things feel nicer. Yeah, it's just like this for loop sucks. No, it's not like that, but like if you're very terse, people there's this thing that we actually do. Someone else came up with this idea called the LOGAF scale, LOGAF, which is level of give a fuck. And what we would do is someone might say on a code review like, "Hey, I think this for loop sucks," and you would be like, "Oh, but this for loop was my life. It was my love." What's your LOGAF on this? And so then they might say like, I didn't actually, it's low. Like, I don't know, I just think it wasn't that great. And you're like, okay, I'm just gonna keep it the way it is then, because your LOGAF was low. Or they might say it was high, like I really actually seriously think about this, and then maybe at that point you jump on a Zoom call about it. Turned out this was a very helpful tool, because then with code reviews, like you can kind of communicate through this scale, like what your temperature is essentially on anything you're saying. But also in code reviews, I think it helped a lot to get rid of the nitpicks. Because I used to nitpick the hell out of people's code too. It was bad. Because then you look at someone's code review and it's like, here's like 12 style things and like one actually meaty piece of advice. And that one meaty piece of advice gets completely lost. Because at this point, they're seeing red after the 5th like semicolon missing comment. And they're mad. And the signal to noise is terrible. And also what can happen is that you can go back and forth and be like, oh, actually, you missed this one. You missed this semicolon. You missed this semicolon. And like by the 3rd round trip, people are it's pissed. It's like mad. And that's not a good way. That's another way to be a jerk unintentionally. Is to just keep going back and forth on code reviews. At some point, just being like, that code's good enough. It's fine. Like code doesn't have to be perfect. Again, what I worry about with code reviews is the long-term effects. Like what's gonna screw me 6 months or 2 years from now? That's what I worry about in code reviews. If this for loop is suboptimal, who cares? Because someone can change that in an hour later. All right, we should go get drinks. If you want to talk to me more, let's talk later.